Hey, so before we start the video, I want to talk about three small things. The first thing is we'll be following the 80-20 rule while I explain the Java. And if you don't know about the 80-20 rule, just do a quick Google search. And the second thing is the method I'll be doing in this video is first I'll explain about the concept, and then we'll do an example on the concept, and then we'll move on to other concept. And the last thing is English is not my native tongue, so please bear with me for the next 1 hour because apparently my English is not good enough. Okay, so it's up to you if you want to code along with me or you want to just sit back and watch the tutorial. It's up to you. Okay, bye. So this is like how the basic template of a Java file is. Okay, and very important thing, don't get intimidated by like any of this. Okay, any of this I'll explain each and every word of it: public, static, void, main. But to understand that, you need to understand object-oriented programming, which I'll explain in just some 30 minutes from now. So let's just now focus on the beginner stuff. Alright. So this is how we print a statement in Java. For a number, you can type it directly, and for a string, you need to keep two quotation marks. You need to keep two quotation marks for a string. So this is how you print something in Java. I'll explain each and everything of this: what is system, what is out, what is print.l. Okay, so now let's talk about data types and variables. Okay, so a variable is something in which data is stored. Okay, consider age is a variable. Okay, we want to store the number 18 in it. Okay, so this is how you store data and variable. Okay, this is variable and this is data. And here, what is 18? 18 is a number, right? Number is also like int, right? So before the variable, we need to say the data type of the variable, which means the type of the data stored in the variable determines the data type of the variable. Means simply here 18, like a number is the type of data stored in the variable, right? So here we'll keep int. So we'll take another example. Here let name be Messi. What is Messi here? String, right? So we'll keep string here. It's as simple as that. So this is the variable, this is the data, and this is the data type. As simple as that. And we also have char. This is a char, another variable, and here if you can notice in int we can't store like 18.1 or something. So for that we have another thing called float. So also here in float you can't just write 16.7. In the end you need to explicitly mention an f, which tells the compiler that it's a float number. Okay. And the last type is, we have many types, but among the primary types, this is the another thing. It's called Boolean. We can have either false or true in it. We can't have like any numbers or something in it. It's either false or true. So now let's print any one of these. Let's print name. And we have Messi in it. Let's print age, or let's print decimal. So that's it about the data types and variables. They're pretty easy. So yeah, that's okay. Now let's see about typecasting. Typecasting is like converting data from one type to another. Not like an integer to an alphabet, not something like that, but like an int to a float. Like an integer is like an integer and float is like a decimal, right? Converting an integer to a decimal type and converting a decimal to an integer type. So mainly typecasting is of two types: widening and narrowing. So like consider two glasses. Okay, small glass and a big glass. A small one can be fitted into a bigger thing, but a bigger thing cannot be fitted into a smaller thing, right? So that's what happening here. Int is like smaller thing and float is the bigger thing. Int can be converted to float easily, like we don't need to say anything, it will be automatically converted. But the bigger thing, aka the float, is the bigger thing, and we need to explicitly mention to convert the float to the int. So that's what typecasting, and now we'll see about it. Like, consider it int age is equal to 10, and now we'll convert that into a float. Is equal to int. So, and now if we print age 1 here, we won't get 10, we'll get 10.0, because age 1 is a float right now. Now it's float, right? So we'll get 10.0. And now we'll see about converting a float to an int type. Okay, so consider this: float age 1 is equal to 10.69 something, and now we'll see int age is equal to age 1. Why am I making so typos? Okay, so now instead of 10.69, here we'll get just 10. The whatever the part is there after this dot, it will all be chopped off. Like, even if it's 10.99, it will be 10. So this is how we convert a bigger type into a smaller type. We need to explicitly mention here. So that's about typecasting. Okay, now let's talk about operators. We all know about operators, they're pretty simple. So let's just go through a quick walkthrough. Okay, consider two variables: int x is equal to 10, int y is equal to 11, and let's create another variable called sum, and we can just keep x plus y in that, or we can keep x minus y. These plus and minus are called the operators. And we also have like conditional operators, which is like x is equal to 10. This is a conditional operator. It's true, right? X is equal to 10. And we also can do something like this: x is equal to 10, and both are true, right? This and means both needs to be true, like this and this. If you keep or like this, any one of that can be true. X is not equal to 9, but y is equal to 11, so it's gonna be true. Now it's gonna be false, and now again both are correct, right? X is 10 and y is 11, so it will show true. And also consider you want to like increase the value of x by 3. What will we generally do? X is equal to x plus 3, but there is another way to do it. X plus is equal to 3. The same applies for like subtraction, multiplication. It's all the same, you know. And the last and kind of important thing, but also easy thing, is the increment operators. Okay, like this. We have two types actually: pre-increment and post-increment. This is like pre-increment and this is post-increment. So what's the difference is, in pre-increment, first the value of x will be increased and x will be used for execution. For in this, first x will be executed and then the value will be increased. Let's work out with this with a simple example. Okay, and now here we type x plus plus. So what happens here is, first x will be printed and then the value of x will be increased. So if you print it here, we'll get 10 only, but if you again print it, if you print the x now, you'll get 11, because first x will be printed here. So 10 is printed here and then the value is increased to 11, and if you print it here, it will be 11, so we'll get 10 and 11. That's it. And now we'll see about pre-increment operator. Here the value will be first increased. See this plus plus, value will be first increased and then x will be printed, so we'll get like 11. As simple as that. So that's about the operators. They're pretty easy, like also important. Okay, now let's talk about operations on strings. Okay, as you know, this is how we write a string. First name is equal to Leo. Now we shall perform some operations on it. Okay, firstly we can do basic stuff like first name dot, like if you keep a dot here, you can get all the methods in it. Okay, what is a method? I'll explain it in a bit. So if you just keep a dot after the variable, you can like get all the functions you can use on that. Like we have like caret, uppercase, lowercase. First we'll convert this to uppercase. And you'll get like Leo all in capitals. That's it. And we can see caret. We want character at the first index, which will be E, right? Caret 1. We'll get E. And we can also print the first name and last name together. First name plus last name. And you might ask, what is this? This is just an empty space. We are leaving the space between first name and last name. Okay, I'll show you it. This is how it is, Leo Messi. But if we keep a space, it will be just a bit more good looking. It's nothing complicated. Yeah. And last thing, we can also like first name dot concat last. Instead of like keeping plus and stuff, we can also do it like this. But it will be like attached like this. And not only this, actually, we can also keep numbers in a string, but we can't keep string in a numbers thing. Okay, string num is equal to 10. You can also print it. It will all be the same. I'm just letting you know that you can also use numbers in this. So that's it for strings, like the basic operations. Okay, so now let's talk about if-else statements in Java. So the basic syntax will be so this is the basic syntax. So first it will check the condition. If the condition is true only, it will enter the loop, or else the compiler is going to skip this entire chunk of code and it will go through the next lines. So the condition needs to be true. And now let's work out with some quick examples. If here we'll keep the condition, if x is greater than 7, print this. X here is obviously greater than 7, right? So it's gonna say greater. But what to do, like consider this condition is false, but we do want another statement, right? Like what to do if this is not true. That's where we use else statements. Like we'll say not greater or something. X is greater than 11. This is obviously false, right? So it's gonna print not greater. And here we can have like multiple if statements. We can have as many as we want. No one's gonna stop us. So we can check for like multiple conditions. X is greater than 21. X is greater than 5. If any of this, if any of this statement is true, any of these if statements is true, it won't go to the else. Okay, if is executed, else will be skipped. Okay, the compiler won't even look at this. It will just skip it and go through the next lines of the code. Like here, this should be executed because like 10 is greater than 5, right? So obviously here we will get greater. Okay, so instead of having multiple if statements, we can also have an else if statement. It's going to do the same thing after all. So Yeah. And now we also have like ternary operators, like consider if we have an if and else statement, like instead of like writing this much amount of stuff, we can do it in a single line. That's called ternary operators. Like int x is equal to 10, right? So we can wrap the result in a string result is equal to x is greater than 7. I'll explain this, wait a minute. Greater, so now let's print the result. So what here it is doing is, right, int x is equal to 10, fine, right? So here it will check the condition. So this is the condition part of the code, okay? Here it will check the condition, like it will say here, if this is true, question mark in the sense true, if this is true, execute this. Like if this condition is true, execute this. If it's not true, execute this. As simple as that. X is greater than 7, 10 is greater than 7, right? So obviously it's gonna say greater. So consider x is greater than 11, it's gonna say not greater. That's it. So yeah, ternary operators are pretty important and pretty easy. Like inline coding, it looks like good, right? So it's good. Like also now consider we want to check for multiple if statements. It looks a bit shabby, and also in ternary operators you can't check for multiple stuff. So that's where we have switch statements. You got it, right? If we have multiple if statements, it's not gonna look good. And in ternary operators we can check only for two cases. So we use switch statements when we want to check for like multiple conditions. Like consider int x is equal to 7. Like here we'll keep x, like here we'll keep the variable through which we want to compare the statements in the switch statement. You'll understand it in a while. Okay, now here we will mention cases. Case 1, we will say Sunday. Okay, and like that we need to print all the cases. Here we'll say break. I'll explain all this stuff in a while, okay? In the end we will keep default invalid number. Okay, 1 2 3 4. Okay, let's 3 days are enough, right? Okay, so let it be Sunday, Monday and Tuesday. Okay, I consider here the number is 1. Okay, so basically this is the syntax of the switch statement. Here we'll keep the value through which we want to compare all the switch statements. Like we want to compare the value in x with all the switch statements, right? Here with which value this case number will be matched, that will be executed. Here x is 1, this is matching with 1, so Sunday will be executed. So Sunday will be executed now. Sunday. So what is this break? Okay, so consider 2 is the correct answer, and if we did not have break, like Sunday will be skipped because it's not true, and Monday, like for 2 Monday will be executed, right? Because Monday is true, like 2 will be matching, and below all that numbers will also be executed. The compiler doesn't care if you don't have break statements. Everything below Monday and Monday will be executed. Like, have a look at it, you'll understand it. See, Monday, Tuesday, invalid number. As you see, Sunday is skipped because 2 is matching, and from case 2 everything below case 2 will be executed. That's why break statement is very, very important. It's mandatory, kind of mandatory. And what is this default? If none of the cases are like matching, then the default will be executed. Default is not mandatory to keep, but it's a good practice to keep. Like consider we keep 11 here. It's an invalid number, right? We only have till case 3 here, so 11 will be executed. Not only numbers, you can keep like strings too. You can keep string name is equal to Messi, and you can have like case Neymar, Ronaldo, Hazard, Messi. Whatever is true will be executed. So it's as simple as that. I hope you got it about switch statement. It's a bit clumsy, but it's easy, right? You just compare the number with all the cases. Whichever case is true will be executed. If none of the case is true, the false statement will be executed. It's as simple as that. I hope you got it. Okay, now let's talk about loops. Okay, so mainly there are while, do while, and for loops, but I'll also say an extra one for each loop. So now let's start with while loop. The main syntax of while loop is as long as this condition is true, doesn't matter how many times the while loop will be still running and running. It's just that it will complete one iteration, right? It will complete the first, it will check for the condition. Is the condition true? Yes. It will complete an iteration, and then it will come up again, then it will check, is this condition true? Yes. So it will run again. It doesn't matter how many times it is, as long as this condition is true, it will be running and running. So let's run a while loop once. X is equal to 10 while x is less than 15. Let's print x itself, and then we'll do x plus plus. You might ask, why are we doing x plus plus? Think once, okay, think once. X is 10, x is less than 15, right? Like 10 is less than 15, right? Yes, it will print x, it will go up again. 10 is less than 15 again. It will forever be iterating, and your PC will just crash. So it will be an infinite loop. See the warning here, is always true. It will be an infinite loop, so we need this. It will run like 5 times now. Yeah, 5 times. So this is it about while loop. We don't have much to talk about while loop. You just keep a condition and keep a code block to execute. As long as the condition is true, it will keep executing the code block. Now let's see about do while loop. Do while x is less than 5. We see here at x is 10. Is x less than 5? No, it's not. So what should it be doing? The program should not perform. But that's not the thing with do while loop. Okay, so irrespective of the condition, the do while loop will execute at least once. Okay, you might keep like -1 is less than 0. Okay, greater than 0. It's false, right? But still the do while loop will execute at least once. So it doesn't matter like how many times. So it doesn't matter of the condition. The do while loop will execute at least once, irrespective of if the condition is true or not. So that's about do while loop. Now let's see about for loop. Okay, the syntax of the for loop might be a bit intimidating for you at the start, but just a matter of time you'll get familiar with it. So don't get stuck about it. Let's just print the I itself, So what's happening here? Firstly, we're initializing a variable called I. Okay, so forget about that. It will get initialized only once. So I is 0, right? You can see it here. I is 0. So at the start of, remove these two. Okay, forget about these two. Just think about the middle one. At the start of each iteration, the compiler will just check about this. Is I less than 5? What is I is 0. I is less than 5. Yes. It doesn't care about anything. It will just go inside. It will execute it. After this is executed, after this line, after this is executed, it will go here and it will increase the value of I to 1. After it increased, then it will again check this condition. What is I know 1? Is 1 less than 5? Yes. It will go execute. Then after executing the code, whatever the code block we wrote here, then it will go again here, and it will, whatever this condition, it will do it. It might be I minus minus, doesn't matter. The thing is, after executing this, it will go here, perform this operation, whatever it is, then again it will check condition. It's true, then it will come here, then the loop repeats on. That's about for loop. See, 5 times. It's pretty easy. I don't know what doubts you possibly could get about this. Yeah, nothing much to think about. And now let's talk about for each loop. Okay, yeah, actually you need to have a bit knowledge about arrays, but yeah, it's fine. Just forget about the arrays for now. I'll say about that after this. Just forget about the syntax of arrays. Just focus on the for each loop for now, okay? So the thing here is, in a for each loop, it will go through each and every element of the array. Like first, for the first iteration, val will be equal to 1 and 1 will be printed. After 1 is printed, it will go to the next element 2. Val will be equal to 2 and then 2 will be printed. And then val will be equal to 3 and then 3 will be printed. So you might ask, why do we use like for each loop? Like if you see in for loop, we need to keep like you saw at condition, we need to keep I is less than arr dot length. We need to keep like I is less than arrays dot length. Like we need to manually mention. But here if you see, we don't need all the conditions. It's just pretty simple. We are taking out each and every element of the array and we are printing that element here. Okay, I hope you got it. Each and every element for each iteration we are taking and we are printing that element, and for the next iteration we are taking the next element and we are printing it, and then we are taking the next element and we are printing it. As simple as that. I don't know why people, I'm not blaming anyone, but people tend to downside this for each loop, but I personally find it like pretty useful, you know, especially during lead code and stuff. It's pretty good. Okay. Yeah, that's it about loops, I guess. Yeah, that's it about loops. Okay, now let's talk about arrays in Java. So if you remember, this is how we write a variable in Java, right? Int num is equal to 10, and it's almost the same for arrays. You just add a square brackets here and you add a curly braces here. That's it. It's almost the same, and you can keep as many elements as you like in this. That's it. That's an array. And you can also like keep a string based array. What shall we keep? Names of footballers. And we can just print it. But here we need to wrap it in a toString method. I will explain it. What is this array stored toString? I'll explain it. We need to study object oriented programming first, and later you'll understand it. See, it's easy, and we can also have some basic operations on arrays. Also we can print a certain element in the array. We can print num of what shall we print? 0. What is the 0th element of num here? 10, right? Yeah. So we shall also like print the 0th element of cent. We should get messy there. 10 and messy. Yeah, we can also change the values, right? Like right now the 0th element is 10, right? We can change it. Num of 0 is equal to 11, and now it's gonna show 11. Check it out. So these are the basic operations on arrays. Yeah. Hey, just adding a bit for the loops. About the continue and break statements. So basically what continue and break statements do is, consider there are 10 iterations in a loop. What break does is, we can mention once the loop reaches the 5th iteration, break the loop, the loop will stop. And what continue does is, if the loop is at the 5th iteration, just skip that iteration. I'll show you now. We'll just print type, and here we will usually get till 9. Here we can show it. If I is equal to 5, we can just hit continue, and see here 3, 4, 6, at the 5th iteration, the condition needs to be added at the top, okay, not before the code block we need to execute. It should be added at the top. Since this condition is met, this loop will be skipped, and if we could break here, the loop will stop executing. See, 1, 2, 3. Usually this is not the method how we use continue and break. We basically use this to find an element, I'll show you it. Int x is equal to 5. If I is equal to x, break. This is how we usually use this continue and break statements. You can see it here. I also change the number. See, it came till 6. It came till 6. 6 iterations are completed, and in the 7th iteration, these two matched, and the break statements was executed, and the loop was terminated. That's it. That's where continue and break are used. Okay, now let's talk about ArrayLists in Java. So basically the thing with ArrayLists is they have almost infinite size. If you see an array, we basically hard code it. We can't increase the size of the array, but we can remove the elements in the array, but we cannot increase the size of the array. But the case with ArrayList is different. We can add as many elements as we want, and the internal working of ArrayList is, consider the initial size of the array is ArrayList is 10, and by the time you add half the elements into the ArrayList, the JDK will create another ArrayList with the double the size of the current ArrayList, and will copy all the elements in the previous ArrayList to the double size of the ArrayList, and it will just throw over the old ArrayList. That's how the ArrayList is always kind of infinite size. The internal working isn't important much, but that's how it works. So now let's see about the ArrayList. So basically here, if you want, you can explicitly mention the size of the ArrayList 10 or something, but we won't, because that's the whole point of the ArrayList, right? Having the size as much as we want. So basically ArrayList is a class, and we are creating a new object called list. But okay, you don't need to know about that, because we did not study object oriented programming, so you'll not understand this, and that is completely fine. Okay, so we are creating a new ArrayList called list of type integer. I think you understood this, right? Okay, so there are literally so many operations you can perform on ArrayList, which you cannot perform on just normal arrays. We can add, firstly we can add it like this, list.add1, and we can also add a certain element at a certain index. list dot add like 0th index. I want to add 1. Let's add 7. We can print the array list. What else shall we do? We can also size, I guess. Yeah, size, list dot size. Let's wrap this in a print statement. Just you can see it here, right? There are like so many methods: dot equals, hash code, is empty, last index, remove all, like sort, do array, trim size. There are like so many methods. Just get some time and just play around with this, right? It's fine, right? To 7, 1. If you see here, we replace the 0th index with 7. And actually you can also use like string here. Of course these all will show errors, but you can also have a string based array list. I also want to say about HashSet. The syntax of the HashSet will be like almost like nearly similar to ArrayList. Here, just here and here, you'll just keep HashSet. The thing with HashSet is, and the only difference between HashSet and ArrayList is, like consider you added some digit like 5 2 times in an ArrayList. When you print it, you'll get like 5, 5, right? But the thing with HashSet is, it does not allow duplicate elements. So even if you add the element twice into it, it will print 5 only once. That's the major, if not the almost the only difference between ArrayList and HashSet. So I thought that was important to let you know. So yeah, that is important actually. So now let's talk about taking input in Java. So we use something called scanner class for that. So now I'll show you the syntax. Scanner. So first and foremost, don't get intimidated by the syntax of this, and don't even think about how to remember this. It's a matter of small time, like 3 to 4 days, and you'll get familiar with the syntax and it will just come with the flow. You don't have to remember anything. Really, you don't have to remember anything. Just have a look at it, work out with it like 4-5 times, and you'll get familiar with the syntax and you don't have to worry about it. And also, if you wonder what this java.util.scanner is, so basically Java is like the main Java package, and util is a package in it. Okay, Java has like multiple number of packages in it, and util or utility package is one of the many packages that Java has. Util, for example, has like many other packages like math package, date and time package, etc. And scanner is one of the package that scanner is one of the class that utility package has. Utility package has like many classes, date and time classes, math classes, many classes, and scanner is one of the class that utility package has. Okay, so here scanner is an here in the scanner class we are creating an object here. Okay, so if you don't know about classes and objects, don't worry, just some 10 minutes and I'll teach about it in OOP part. So it's not important for this, forget about all that. This is just the syntax to take input in Java. Don't worry about anything, you will get familiar with this and you can use it. Forget about classes, objects, everything. This is just the syntax to take input in Java. Okay, so now let's take some real input. Enter your and now let's take an input. Okay, so what's happening here? What is this line? Okay, so in Java, while taking input, doesn't matter. Okay, in Java, while taking input, doesn't matter how many times you want to take input. this line should be only once, like the main initialization line. Okay, this is called initialization of like taking input in Java, kind of like something like that. Initialization of taking input in Java. For that you need to type this line only once. Okay, and you need to take input like multiple times. Here in this line we are taking input once, here in this line we are taking input once. Okay, so I hope you got it. And what's this? Okay, so basically this is taking an input. Okay, this is taking an input, and that value is being stored in the variable called name, and that value, okay, and that value in the variable name is of type string. Right, I hope you got it. Let's try this one again. Okay, we are taking a input. Okay, we are taking input, we are taking some data as input which is of type int. Okay, and it is being stored in a variable called number. Okay, so what is the type of the data being stored in the number? Int. So here we are having int. Okay, so int number scanner dot next int. I hope you got it. So now let's print out name. I love Messi. Here it is. Your favorite footballer is Messi. It's as simple as that, I hope you got it. This is the initialization line, and this is the line to take input and store it in a variable, and here we are printing that variable. As simple as that, taking input in Java. Okay, I hope you got it. And we kind of completed the some part of Java, and now my charge is out, I guess. Okay, now we'll start object oriented programming. I think we covered everything in like general Java right now. Loops, if else statements, operators, variables, data types. What else? I think that's it. Yeah, I don't know, maybe something left. I'll think about it. So yeah, we'll start OOP in a while. Chill, have a break, and we can start OOP. Okay, so now let's learn about methods in Java. So first, how we create a method is, this should be outside of the, like here we have main method, right? Main is a method, alright. Outside of the main method, not inside of the main method. Okay, we'll say public static void, what we'll say, my method or something, and we just print a statement. Okay, football, and here we can just call this method. Okay, this method's name is called my method. And what does this do? What does this method called my method do? Just print this statement called I love football. And what will happen now if we call this method? It will just print that statement. That's it. I love football. Yeah, we can call it as many times as we want, And you might ask me, okay, what's the actual reason of this? Like, why do we even use it? Okay, so there are many reasons, but the most important ones include, firstly, consider printing out this like 3 times. Isn't it a bit clumsy when compared to this? Okay, if you're not feeling like this is clumsy enough, what if the statement was something like this? We can't just it really looks clumsy right now, so we can just call it out as a method, right? So that is one reason. And if you remember, during strings back in the video, for a string I'll create another string, right? Here if you see, for a name we have 2 lowercase, 2 uppercase. These all are called methods in a string class, alright? So these are all methods. Like this we can create methods. Like this method prints a statement, right? In the same way, the 2 lowercase method converts the characters into lowercase. That's the whole point of methods. And also like that's the whole point of method, to like a certain characteristic would be kept in a method. Like consider a car, like turning on the car is a separate method, driving the car is a separate method. Not everything will be included at in one place. It will like be cumbersome and clumsy. So like that, like let's create another method, public static int sum, and this will take two numbers, okay, int x and int y, and it will return x plus y. And if you are thinking like here why did I keep void and here why did I keep int, void in the sense we are not returning anything, okay. Here are we returning anything? No, we are just printing a statement. Int in the sense we are sending something to the upper thing, like we are returning an integer value here. What is x plus y? Obviously an integer, right? Int plus int is equal to int. Here we are returning an integer, so here we are keeping an integer. If we are not returning anything, we will keep void here. Okay, I hope you got that. So now I will call that method sum of what shall we pass, 1 comma 2. So now just passing is it enough, right? We need to pass it, we need to like print it, right? First we shall store it in a variable called ans, and we can just print the ans. See, 1 plus 2 is equal to 3. That's it. That's it about methods. Actually there's nothing more or complex to speak about. As simple as that. Methods, now you create a method, you call the method, and you use the method, and yeah, that's about methods. Okay, so we are entering into object oriented programming now. So basically the entire OOP is like mainly based on classes and objects. So it's really good if you could like clearly understand what classes and what objects are. They are essentially simple stuff, so you'll most probably understand it. Okay, so what are classes and what are objects? So consider a cookie cutter and a cookie. Alright, so like what are cookies here? Cookies are objects, right? Basically cookies are objects. And how are cookies made? Using cookie cutters. That's it. Objects are made using classes. Like a class can have multiple objects. Like using a cookie cutter we can build multiple cookies, right? In the same way, using a class we can build multiple objects. That's it. So basically a class is like a blueprint for the object. It's like you've seen a cookie cutter, right? It's just a blueprint of how the cookie should be, right? That's it. That's it. So a class is basically a blueprint of how the objects can be. Using a class you can build like multiple number of objects. That's it. That's what class and objects are. Now we'll code it and you'll like understand it more clearly. Okay, now let's code classes and objects. Okay, so this is a class, main is a class, alright, but we'll create another class now, our own cookie class. So basically this is the syntax for creating a class, and here you'll have the class name. That's it. Class is a keyword, okay, and class name is a variable, like name of the class. Actually the class name should be capital, and as we spoke, it needs to have some property, not mandatory, but we'll have some properties in it. What properties can we have? Size, string, shape. You can also have color property. Now we'll create an object using this class. That's it. This is how easy it is to create a class. Now we'll create an object using this class. Okay, That's it. We just created an object using this class. Okay, so what's happening here is, this is the syntax to create an object using a class. Here we'll use the class name, like using for this class we want to create this object. Okay, for this class we want to create this object. And what is new here, this is an assignment operator, we know. What is new here? It's telling the compiler to create a new object. What is that new object? This new object. Where is this new object being created? In this class. Alright, this cutter is called a constructor. Okay, by default it's called a constructor. It's basically used to like initialize objects, and there are like many more uses of this constructor. We'll just get to know about that in a minute. Now we'll set up these properties: size, shape and color. By default this will be like null. I mean null in the sense, for int it will be null, for string it will be like two empty quotation marks. Now we'll just initialize that. Alright, so how do we set up this size property for this cookie object? Okay, this is how we set it up. Cookie dot size is equal to something like 10. Now cookie dot what's that, shape, right? Shape is equal to what shall we keep? Circle. Cookie dot color is equal to what? What's the default? Sand color, right? Brown. Okay, that's it. Now we can, that's it, we've created an object. We created an object called cookie in the class cutter, and now we also have set up properties for the cookie object. Now we can just print out them. Cookie dot we shall print out this size. You can print out everything, not everything is necessary, so we'll just print two properties of the object. 10 circles. That's it. So what happened here? Actually, we created a class, and then we created an object using that class, and we set up the properties for that object, and we just printed out the properties of that object. That's it. Okay, now let's talk about methods, this keyword and constructors and its types in Java. So basically a method is a function, but like a function in a class is called a method. Alright, yeah, methods are pretty important. Yeah, let's code a method now. Void what shall be the name be? Print me. This is like the syntax of creating a method, and here we will write the code, like what the method should do. For now, let this method just print something, hi. Now this method doesn't print by itself, we need to call it. Where do we need to call it? In the main statement. Okay, since this method is associated to this object, we need to do it like this: cookie dot print me. That's it. See here, hi. So basically, if you observe by now, this is how we print a scanner class, right? If you observe, scanner is a class, and in that we are creating our object called scanner. That's it. That's how we did this, right? That's what I said when I was teaching about input classes. Scanner is an scanner. We are creating the scanner object in the scanner class, right? That's it. And all, like, if you see it here, cookie dot get notify, like if you see here, all these are methods, right? Like the default methods: get class, toString, hash code, and this is our custom created method. Okay, all these are like default methods, but this is our custom created method. Also, like there is a math class in, I will show you it. Math dot, all these are like the methods. Math is a class in Java. Okay, first there is a utility package in Java, and then math is a class in Java. In the utility package, math is a class in Java, and these are all the methods that are in the math class. Alright, like in the cutter class, these are all the methods. In the same way, in the math class, these are all the methods. The thing is, these come by default, and we just coded this method. That's it. Classes and methods, they are like simple. And now we shall talk about constructors. Okay, not just this, we can create our custom constructor. This constructor comes by default. Alright, well, let's create our own constructor. Constructor will always have the name of the file. Okay, like cutter is the class name, right? It will always have the name of the class. The name of the class and the name of the constructor should be same. If they are different, then it's not called a constructor, it's called a method. Okay, so now let's create a constructor. Alright, the constructor should always have the same name as the class. Okay, so now what this constructor does is, let it accept some values. Int size, shape. Now let's pass the values. Let the size be 11 and the shape be triangle. Okay, so if you observed recently, we were doing it like cookie dot, and we were doing it, but like this now, if we pass the values, we can just like set up the method here, like this dot size is equal to size, and this dot shape is equal to shape. Okay, so what is happening here? So first we created a constructor and it's accepting some values. What does this dot size is equal to size mean? Okay, so how did this cutter like constructor get called? What called this constructor? This cookie object called this constructor. So understand this object called this constructor. In this in the sense, this object, not exactly this object, the object which called this constructor is called here, like this. Okay, so for that object, set the size property to size. Okay, that object has a size property, right? For that object, set the size property equal to size. Right, that's what happening here. So that's it about constructors. And this keyword and methods. Okay, now let's talk about the differences between constructors and methods, and about constructor overloading in Java. Okay, so what's the difference between constructors and methods? Actually, I shouldn't be asking this question after what I explained, like this is a method and this is a constructor. But even if you have any, like if you can't identify the difference, that is totally fine, you'll get along in the way. Okay, so think by yourself, what's the difference? Okay, this is a method, this is a constructor, what differences did you find? Okay, so firstly, this public, private, those are called access modifiers. Okay, constructor doesn't have an access modifier, that's the first thing. And this void here, you see, right, it's called a return type of this method. This is the return type of this method or this function, whatever. Constructor doesn't have a return or return type. Okay, so and the last thing is, if you see here, method can have any name, literally like any name, but the constructor needs to have same name as the class. It can't have like any other name. So yeah, those are the three main differences between classes, methods and constructors. There are many other, you could just go and look it up yourself, but there are many other, these are like the main key differences. Okay, and what's the other thing? Constructor overloading. Okay, so what is constructor overloading? I'll show you. That's it. We just now created another constructor which accept only one one attribute. Okay, these are called like attributes or something, and these are called instance variables. Okay, the variables which are like initialized in the class are called instance variables, and these things here are called attributes. Okay, so yeah, now if you see here, we are passing two like attributes. So like bro, we have two constructors, right? One accepts two attributes, one accepts one attribute. Since we are passing two attributes here, the constructor which is accepting two attributes is called. Now let's pass only one attribute here. Okay, so here passing one attribute here, so the constructor which accepts one attribute is called. You can see it here, this is highlighted. Okay, that's it. That's called constructor overloading. The compiler will check by itself and call the appropriate constructor. That is called constructor overloading. Was it really lagging? I don't know how it's gonna be in recording. Let's see. Okay, now let's talk about keywords, interfaces and polymorphism in Java. So in keywords, first let's talk about static. Okay, so what is static and what does it do? Static. Okay, so static allows us to create members that belong to the class, not the instances of the class. Like instances in the sense the objects we created using the class. So static allows us to create members in the sense like variables or methods that belong to the class. Okay, not to the object we created, they belong to the class if we use static. So that's what static helps us to achieve. So I completely understand that you did not understand anything from the definition, so let's code it and you'll most probably understand it. Okay, so first let's talk about static variables, then we'll talk about static methods. Okay, so here we have this variable, right, int size. This is like a normal variable, it's not a static variable now. So let's create an object now. So we create an object called cookie of the class cutter. Alright, so now cookie dot size. What is this? Okay, so here we have this size, right? This size belongs to this cookie object, and now we'll increase it. Okay, now it will be 11, right? 10 plus means 11. Now we'll create another object. Cookie 2, and we'll create another object called cookie 3. Okay, in the same way we'll increase the size for cookie 2 dot size. Okay, now let's print it. Okay, firstly understand this is a different object called cookie, this is a different object called cookie 2, this is a different object called cookie 3, but all those belong to the same class called cutter. I really hope you understood this. Okay, so now let's print out the size of this cookie and this cookie. Okay, cookie dot size, cookie 2 dot size. Now what will it be? 11 and 11, right? 11 and 11, because we created an object called cookie of the cutter class, and then we increased the size in this object, and in this object we increased the size, we just printed it. Now what will happen if we print the size of this cookie 3? Obviously it's gonna be 10, because the size we increased belongs to this object. This object's size we increased, not any other objects. This object size we increased. See, 11, 11, 10. Okay, so that's the general way. Now what's with static? Now if you see it with static is like this size variable is created only once. Okay, so basically when static was not there, every time a new cutter, every time a new object in the cutter class was created, a new size variable was created. Okay, so for these 3 objects, 3 size variables were there in the memory. But since we are using static now, there is only one. I repeat, since we are using static, there is only one size variable, and all the objects are using only this size variable. Okay, whatever object it is, all have the same size variable. Okay, so we created this object called cookie. We increased the size of this object, but what did I say? All the objects use the same size variable. So since we increased the size is now 11, and in cookie 2 we increase the size. Since the size variable is same for all, the size is now 12. So what's gonna happen now? What will this print? All will print 12 only. 12, 12, 12. That's what I'm trying to say, I hope you got it. Like, there is only one size variable. Every object will use that size variable only. That's what I'm trying to explain. I hope you got it. Okay, so now let's talk about static methods. I think you should have known by now how to create a method. Okay, static void add num. This method, okay, add num is a method, and it will take 2 parameters, int b. We will just print out the sum of a plus b. Okay, so the thing with static methods is, okay, consider there is no static. How will we access this method? Generally asking, how will we access this method? First we will create an object of the cutter class, and through the object we will access this method, right? Okay, so first let's create an object of the cutter class, and from this cookie dot add num, and it will obviously print 3. So the thing with static is, you don't need to create an object to access this method. You don't need to create this object to access this method. You can just remove this off. You can add static here. You can just keep the class name, and you can access all the methods in the class. That's it. If you have a static method, alright. Okay, I'll tell it again. If you have a static method, okay, if the method is static, you can access it directly through the class instead of creating an object of the class and accessing it using the object of the class. Okay, you don't need it. You can directly access the method using the class if it is a static method. Okay, so I will give you another good example. If you have noticed, we have this thing, right? Math dot anything. Okay, consider math.max. As I already told, Java has a package called utility package, and in that utility package, math is a class. Okay, math is a class like cutter, and in that max is a method like add num. Okay, then how are we accessing this method? Okay, math is a class, max is a method. how are we able to access this max method without creating a class of the math, without creating an object of the math class? Since this max method is static, we are able to access this without creating an object of the math class. Okay, that's the same thing happening with this cutter class. That's it. That's the thing about static methods and variables. Okay, now in the keywords part, let's learn about access modifiers. Access modifiers in the sense public, private, final. So what they do is they determine how you can access the stuff, like be it a function or a class or a variable, anything. It shows like to which extent it is access it. Consider a CBI office or something. The data is like private accessible. Means not the public cannot access it. It's just that group of people, whoever work there, can access it. Same here, consider this function public void add num something, right? Now I will turn it to private. First let it be public. Let's create an object of the cutter class here. So basically we can access it now, right? Add num. We can access it now. But if we turn this private, we can't access it. So what private does is, whatever it is, be it a function or a variable, it's just accessible to that class. Okay, this class is called cutter. This is a class called main. What did I say? It's just available to that class. So obviously it's gonna show error here. Private access. That's what I said. So that's it about private and public. Nothing much to speak about. Okay, so what's default keyword? Default in the sense, here you can see, right, this class does not have anything, neither public nor private. This class has public. Public in the sense, it's like accessible literally everywhere. You can create another file here, another class here, and you can access this class from that newly created class. You can literally create like 100 files and you can still access this public class, public class or variable, whatever it is. So if we did not explicitly mention anything like public or private, then it will have default class. We don't type default here, it will automatically, the compiler will consider this as default class. Okay, so according to default class, it's just available in this file .java. It's showing file, right, this class and this class. That's it. That's about default. Default we don't use much. We just use public and private. We also have other class called protected class. We protected modifier. We don't use those much. We just use public and private. Okay, so what's with the final keyword now? So what final keyword does is, you can't we use mainly use those for variables. We can't change the value of the variables. We want to keep it constant, then we'll use the final keyword. Consider this now, cookie dot size plus. This will increase the size of the cookie by 1, it will go to 11, which means this size variable is modifiable right now. So what if we make this final? It will show an error, obviously. Cannot assign value to a final variable. As I said, if it is a final variable, we can't change the size. We can just use it to print or something. We can't change the size if it's a final variable. That's it about final, private, public. So function return types. Okay, so as you know, this is a function or a method, whatever. This has return type called void now. Means it is not returning anything. Is it returning anything? No, it's just printing stuff. Returning stuff in the sense, I'll show you. A plus B. This is called returning. It's returning something. What is that? What is this function returning? A plus B. What is A plus B? Consider this is 1, this is 2. What is 1 plus 2? 3. What type of data 3 is? It's int. So we keep int here. Okay. Void in the sense nothing. Not 0. Nothing. There's a difference between nothing and 0, right? 0 is still int. I'll show you. Return 0. 0 is still int. there is a difference between nothing and 0, right? So yeah, we can just like cookie dot add num of 1, 2, we can print it. Can print it. That's what this is return type. We can also return it in a string, whatever. That's it about this. Okay, now let's talk about inheritance in Java. Okay, so what inheritance does is, you can like each class has some methods, right? This method or some variable, you can inherit those methods or variables into another class. Okay, so like let's consider a good example. Consider you have a rich father and you are a selfish guy. Okay, rich father and you are a selfish guy. Your father is something worth around $15 million, 1-5, and you are worth around $5 million. So obviously, and you're the only son, so obviously you'll inherit his fortune. So now you will be worth around 20 million. But as said, you are a selfish guy, so how much would your father be worth now? 15 million. So that's the same thing with this inheritance thing. So let's create another class, we'll get to know. Cutter 2. So how we inherit, like I want to inherit all these into this new class. How will we do it? So extends, so here we'll use the keyword called extends cutter. So with this, all the properties in the cutter will be available in cutter 2, but none of the properties in cutter 2 will be available in cutter 1. I told you, right, the rich dad example just now. Same thing here, all the properties in the cutter will be available in cutter 2, but none of the properties in cutter 2 will be available in cutter. That's it. Let's remove this. So here we have this red public int add now. Let's create another one here. Subtract now. Okay, now let's create an object of cutter 2. Okay, cutter 2 cookie. Now if you see here, cookie dot add num. Where is add num? In the cutter class, but cookie is an object of cutter 2 class. Then why are we able to access it? Because of this, we are inheriting cutter class. Okay, so for cutter 2, cutter is called parent class, and for cutter 2 is called subclass or else child class. So yeah, this is it about inheritance in Java. It's nothing much. We are not printing it here. Okay, whatever, we need to add a print statement here. Okay, so this is it about inheritance in Java. We just extend a class. We can also like multiple classes, like another class can extend, like cutter 3 can extend cutter 2 again. Then cutter 3 will have all the properties of cutter 1 and cutter 2. Hierarchical inheritance, And yeah, multiple classes can also extend cutter. Like we will create another class called cutter 3, and it can extend cutter 2. These two, like we can do it like this too. It's up to us. So yeah, this is about inheritance in Java. Okay, now let's talk about polymorphism in Java. Polymorphism is mainly of two types: method overloading and method overriding. Overloading and overriding. Okay, so overloading is fairly simple. So now first let's talk about overloading. Okay, so consider there are two functions. one takes 2 arguments, the other takes 3 arguments. Function name is same. Okay, that's the main point. Function method name is same. Right. Now we created an object here already, cookie object from the cutter class. Okay. If you notice here, we sent only 2 numbers. Which method here takes only 2 arguments? This one, and Java automatically called that. That's it. It will automatically, for this C, it automatically assign list to one which takes 3 arguments. That's it. That's what method overloading is. It finds the correct one which takes the appropriate number of arguments, and it will assign to that. That's what is method overloading. And now let's talk about method overriding. Okay, in polymorphism, method overriding. Okay, so first let's clear this class and let's create another class called animal. Okay, this will just have a function which will have a print statement, void sound. Let's create another 2 subclasses for this. Okay, this is the parent class, these 2 will be subclasses. Dog extends animal. Okay, so here we have 3 classes now, in which one is a parent class and 2 subclasses are extending the parent class. Okay, so generally how do we create like the normal object? Animal is equal to new animal, and here you would obviously be like not gonna access this sound method using the object created. You can access that. But what is polymorphism? I mean method overriding. I'll show you now. Animal if you see this now, animal 1.sound, it will be dog, even though here we have animal. Bow means dog. So what is that? What happened here? So basically here animal, this is called reference type and this is called object type. Okay, so reference type, what does reference type determine? Reference type determines which methods can be accessible. Okay, like see here in animal sound method. So if you keep animal here, whatever method you keep here doesn't matter, you would only be able to access this method. Okay, since we have a reference type as animal, we would only be able to access the methods that are present in the animal class. Doesn't matter what you keep here. Instead of animal you can keep something, doesn't matter, but we would only be able to access methods that are present in that class. Like consider dog. In this dog class, instead of sound we will keep like a walk or something. You won't be able to access it because we will be only able to access methods in the animal class. Alright, so we create is the method of which class to be used. Okay, animal says which method to use. This dog says the method of which class to use. Okay, I hope you got it. It's kind of hard, but I mean it's hard in the start because you need to use it with an example. Like, so basically this says which methods are accessible and this says which implementation of the method should be executed. Like the method is already executed in cat, dog, so this says which methods are accessible, and this is which of the accessible methods should be implemented or executed. That's it. That's like polymorphism. Okay, now let's talk about encapsulation. So basically encapsulation is like a principle where you know just like bundle all the data, okay, all the data into a single class. All the data in the sense like all the methods, attributes, everything. So that's it, you bundle all the data and like protect them like non-vulnerable, in a style of non-vulnerable methods. So like all the methods classes, almost all the methods and classes will be set to private, which means you can't access those variables and method outside of that class. Right, what's private, so you can't like access none of them outside of the class. And if you want to like read or write those data, we use something called getters and setters. Okay, using getters and setters we read any data like a variable or something, even though it's private we can read and modify the data. So that's about encapsulation. So you might get the doubt like where exactly when use this, what's the use of this. So basically it like increases security like too good, because no one can even access it like from outside of the class, and it's basically used in like banking systems or in unit tests during a company run, something like that. So now let's write the code for it and you'll get a like even more good view of that. Okay, so let's first create a class. What shall the class name be? Class name, let's create a private string name. Okay, now let's create an object of the name class. Now obviously we won't be able to access this name variable because this is private. We can try it if you want. We can't accept it. Then how do we read the name of this? How do we set the name of this? That's where we get getters and setters. Okay, first we'll build a setter to set the name to this. Okay, public static void set name. This dot name is equal to name2. And now how do we read the name of this from an outside function? We use getters for that. Okay, public void get name. Actually this should be a string type return. That's it. This is called encapsulation. Okay, now let's try some examples with this. Okay, name1 dot set name messy. Now we will get that name, name1 dot get name. Actually let's print that. Now let's see messy. That's what encapsulation is. We will set some data in it which we will keep private, which means we can't access it from the outside. So we need some or the other way to like set the name and get those details. That's where we use set name and get name functions. I think there is no doubts you could get in this. Maybe this might be a doubt you might have. What is this dot name? Okay, what did I say about this? If you go a bit back in the video, what does this refer to? Okay, so what is this? Leave this. What is this? This, right? What is it? This is a method. Okay, who called this method now? Who called this method? This object called name1 called this method. So this refers to the object that called this method. Okay, so this refers to the object that called this method, means this is referring to name1. Okay, that's it. it's setting the name variable in name1 equal to this name2. I hope you get it. Okay, this object called this. So name1 called this set name method, and this yeah, that's it. Okay, now let's talk about abstraction. Okay, abstraction, abstract classes and stuff. So abstraction is like hiding the unnecessary details to the user. It's like we show them what to do but not how to do. Like consider a TV remote. To decrease the volume we need to press this button, to increase the volume we need to press this button. Like they know what to do, like press that button, but they don't know how to do, like all the internal remote signals and stuff. So abstraction is something like that. It simplifies the UI component and stuff. Like it simplifies it. Okay, so what are abstract classes? Okay, for abstract classes, consider this is just a normal class and this is an abstract class. That's how we create abstract classes. So what's the difference between abstract class and normal classes? For normal classes we can create objects, right? For normal classes we can create objects, right? For abstract classes we cannot create objects. Okay, we cannot create objects for abstract classes. And yeah, that's it about abstract classes. And what about abstract methods? Okay, abstract methods are like single line function. They do not have any code or body in them. And abstract functions can only be in abstract classes. We can't write abstract functions in outside of the abstract classes. Okay, abstract classes can have both abstract methods and normal methods, but yeah, abstract methods can only be there in abstract classes. Okay, so yeah, that's it about abstract classes and methods. We shall code an example now, and hopefully you'll understand it. Okay, so yeah. Okay, so now let's create an abstract class, and then we'll create an abstract method in it, and we'll just try around stuff. So first let's create an abstract class animal. Yeah, this is how we create an abstract class. No other special syntax for it, we just need to mention abstract. Now we'll create an abstract method. Okay, public abstract void, what shall the name be? Sound. Yeah, this is an abstract method, and we should create another normal public method. Public void walk. Walking. Okay, now we'll create another subclass for this animal class. Okay, we'll like extend the class dot extends animal. Okay, now we might think, why is this showing error here? So the problem here is when we inherit from an abstract class, we need to have at least one abstract method from it. So here this is the abstract method, right? Sound. So we need to have that sound method in this. You can just click this here and we can get it. So yeah, so this is like the template of the method, and we are implementing our own sound method in this dog class. We can have as many implementations of this as we want. We can create another class called cat, and we can implement sound there again. It's our call. So yeah, now this will say Bob. So yeah, this is all about abstract classes. Now we'll create an object of the dog class, because we can't create an object of the abstract classes. We'll create an object of the dog class. Dog is equal to dog. Now we can access all this. We can access sound, we can access walk. Okay, now we'll say new dog dot sound, we'll say new dog dot walk. So this is about abstract classes. The main place where abstract classes are used is, so that's it. Abstract classes are used in like creating template for other classes. Okay, so like you see here, right, it will just implement abstract methods like this, like just start like implement abstract methods like this, and every other class that extends the abstract class will have their own implementations. So yeah, that's it about abstract classes. Okay, now let's talk about interfaces, probably the last oops concept. So yeah, okay, what are interfaces? Okay, as we know, classes are blueprint for objects, right? Classes are blueprints for objects. Interfaces are blueprints for classes. Okay, that's the thing. Okay, so what does an interface do? Basically, interface defines a method. Okay, understand this. It defines a method. It does not code a method. It defines a method. Whereas the classes which inherit the classes which inherit the interface will implement the method. The interface will just define the method. Understand that? Okay, interfaces define the method. The classes which inherit the interfaces will implement the method. Okay, so a good example for this would be, consider an interface called car. Okay, and there are multiple classes like a Mercedes and an Audi. Consider those two. In a car interface, we will have a method defined called start button. Okay, what the fuck is, so consider an interface called car. Okay, an interface called car and two classes, okay, called Mercedes and Audi are extending, okay, are like child classes of the inheritance. Consider it like that, extending the interface. Okay, so as we said, interface defines method, it does not implement them. It defines method. Like, so consider a method called start. Interface just defines it, means it says that the classes that inherit me should have a method called start. It's mandatory. Okay, the classes that inherit me should have a method called start. It just says that. Okay, just creates an empty function and leaves it. The classes which like inherit the interface should implement that start. Like interface says the car interface says car should have a start button. Okay, start, and it's up to the cars how the start button will be, because we said Mercedes and Audi, right? Consider in Mercedes it's a touch button, and in Audi you need to use a key. It's up to them. It's that they need to have a start button. It's up to them how they have the start button. So Mercedes will have a touch and Audi will have a key. That's it. That's about interfaces. Let's code it and you will have a like full brief overview about it. Interface car. These people shout. Okay. Interface car. Void start. That's it. Okay. Now let's create a class. Class Audi implements. Okay, this is the important of. We don't use extends here. Okay, because this is an interface, not a class. So to like use it for an interface, we use implements, not extends. Okay, class Audi implements car. This will show an error because as I said, it should implement the method that the interface has. It's mandatory. See how the error goes after we implement the start. Public void start. I said right. So Audi. Now we'll create another class implements car. Okay, so yeah, this is it about interfaces and classes. One thing with interfaces is you can implement multiple interfaces. That's the good thing with the interfaces. You can just create another interface and just do implement again. Okay, so now let's create an object of the merc class. Merc is equal to new merc start. That's it. Now we can do another one for Audi too. It will just say Audi. So yeah, that is it about interfaces. And instead of cars, we can here use like, here we can say payment, here we can say credit card, here we can say PayPal, and here we can just say paid using PayPal, here we can say paid using credit card. Like, I'm just saying examples. Okay, so I really hope you understood about interfaces. Okay, so yeah, that's okay. So the very last thing is about, we'll talk about the syntax. I'll explain about the syntax. Okay, so let's start from here. Public. What is public? So public is an access modifier, as we spoke. Why did we keep public here? Firstly, public is not mandatory to keep here. We can remove it here, but it is a good practice to make this main class accessible from any file in this thing. Okay, outside of this main.java file also, main would be accessible. That's why it would be a good practice to keep public. It's not mandatory. We can remove it. It's not mandatory. And class is a keyword for creating a class. For what? Main. For creating the class main. Okay, class main. Okay, why is it main here? Firstly, that name is our wish. We can change it, but as we said, here the name of the class and the name of the file should be same, so it's main here. If you want, you can change the name. That's not mandatory. Okay, so public here. Why is it public? Why can't? Okay, firstly, this is a method. Okay, inside a class, this is a method called main method. The name of this method is called main. Okay, so why is this method public? Why can't it be private or anything? Firstly, the Java compiler, okay, the JVM machine is outside of this class entirely, so it should be accessible. So it should be able to accessible this main method, right, to compile. So that's why this is public. Okay, so what is static? Static, I said about it. To be able to access any method without creating an object of it, we need to have static. Okay, JVM cannot create any objects, but it should be able to access this method. JVM cannot create any object of the class main. Okay, object of the method, object of the main using this main. Okay, I'm saying JVM cannot create any objects, so that's why, and it should still be able to access this main method. That's why we have static here. Void. This JVM does not return anything, it just executes what we gave it. That's why it's void. What is main? As I said, main is the name of the method. Why can't we change main, the name of the method main? Can't we keep any other thing? No, we can't, because JVM specifically looks for a method called main to execute it. You can't have two main methods. Okay, there will be only one main method and JVM will be looking for it, so we can't change it. What is the string args? You know, when we give inputs, right, to the scanner class, we used to take inputs, right? So for the JVM to take inputs, this is like the parameters. Okay, like in a function we'll keep, right, in the brackets, public void sum of int a comma int b. Like that, string args is also a parameter. Okay, what is this args? This is called, like, string is the data type and args is the variable. Okay, we are taking input, right? The input we are taking is of a type string that is stored in an array, and the input we are giving, right, the data, that is stored in a variable called args. We can change it. Arguments, we can change it. It's our wish, but we can't change this because it is being stored in a string in an array, and it is being passed. Okay, so I really hope you understood about this syntax. I think I explained every word of it. Hopefully you understood it. Okay, that's it. Okay, so I think we are done for this lecture because we covered all the basics and we also covered the OOP concepts. So OOP mainly consists of main four concepts called the big four, and they are abstraction and interfaces. We know about abstraction interfaces, right? Like hiding all the unnecessary data and having only the important one, showing only the important one. Like I told you about the TV remote, right? We will show what but not how. Okay, that's about abstraction interfaces we just covered now. It's like a blueprint for the classes. And encapsulation in the sense storing all the data in a class and then using getters and setters to access and modify the data. And polymorphism, method overloading and method overloading and overriding, we covered about that. And finally inheritance, like class extends class. Like I told you, right, millionaire father and self-centered son 15 million, 5 million, yeah, that example. So yeah, we covered all the basics and we covered all the OOP concepts. Yeah, that's it for the video.